Welcome to the DIY Honda Garage channel. The DTC P0339 indicates a problem with the Crankshaft Position CKP Sensor Circuit in the Honda Accord 2023 Plus. This diagnostic trouble code signifies an intermittent interruption in the sensor circuit, which may result in erratic engine behavior. The CKP sensor plays a crucial role in determining the engine's position and speed, allowing the Powertrain Control Module, PCM, to manage fuel injection and ignition timing effectively. This sensor is typically located near the crankshaft, directly affected by the engine's rotational movement. An issue with the signal received by the PCM can lead to poor engine performance, stalling, or difficulty starting. As such, diagnosing this condition promptly is essential for maintaining vehicle functionality. The Crankshaft Position CKP sensor is integral to the Honda Accord's engine control system. It monitors the position and rotational speed of the crankshaft, providing essential data to the Powertrain Control Module, PCM. When the CKP sensor malfunctions or experiences circuit issues, it can lead to the generation of DTC P0339. The PCM is designed to detect if the pulses generated by the CKP sensor deviate from predetermined values, indicating that an abnormality exists. This sensor is usually situated on the engine block, in close proximity to the crankshaft, making it susceptible to wear and tear due to heat and vibration over time. If the CKP sensor fails, it can disrupt the vehicle's ignition and fuel delivery, ultimately affecting overall performance. There are several potential causes behind the DTC P0339 code. First, a faulty CKP sensor may not transmit the correct signals to the PCM, leading to erratic engine behavior. Second, weak circuit connections and loose terminals can create intermittent issues within the CKP circuit, causing the PCM to register an abnormal condition. Additionally, the CKP pulse plate, which is crucial for generating the reference pulses, can become damaged or loose, affecting its operation. Grounding issues, either at the engine ground or body ground, may also contribute to circuit problems by causing insufficient electrical flow. Thus, each of these points must be thoroughly inspected to diagnose the root cause effectively. The manifestation of DTC P0339 can lead to various symptoms that may indicate an underlying issue with the CKP sensor circuit. One of the most common symptoms is engine stalling, which occurs when the PCM fails to receive correct timing information for fuel injection or ignition. This can also manifest as startup difficulties, where the engine may crank without turning over efficiently. Drivers may also notice erratic engine performance, such as unusual acceleration or misfires, particularly during specific driving conditions. Additionally, the check engine light will typically illuminate when this DTC is present, providing a clear indicator for further investigation. Recognizing these symptoms early can prevent further complications and maintain vehicle safety. The first step in troubleshooting DTC P0339 is conducting a confirmation procedure. Start by allowing the engine to idle for at least 10 seconds. This step is vital for gathering initial data under stable engine conditions. During this time, use the Honda Diagnostics System, HDS, to monitor the OBD status specifically for DTC P0339. This will assist in determining whether the error code recurs during normal idle operation. If the code is recorded, it indicates that the issue remains unresolved. Completing this procedure is crucial, as it sets the stage for further diagnostics by establishing whether the problem is persistent or an intermittent fault. Following the confirmation procedure, The next step involves a test drive to monitor the vehicle under real-world conditions. Drive the Honda Accord for several minutes, focusing on maintaining parameters such as engine speed and vehicle speed. Keep an eye on the HDS to check for any reoccurrences of DTC P0339 during this test drive. This step is significant as it helps to see if the issue is intermittent, potentially providing insights into the conditions that trigger the fault. By collecting data while driving, the technician can compare these readings against the normal operating range expected for the vehicle, allowing for a more informed diagnosis of the CKP system. The third troubleshooting step focuses on inspecting the CKP sensor circuit connectors. Begin by checking the connectors for secure connections at both the CKP sensor and the PCM. This is an essential process to ensure that they are properly seated and operational. Inspect the terminals carefully for any signs of looseness or corrosion, which could interrupt the circuit and lead to signal issues. It is crucial to ensure that all conditions at these connections are deemed okay, as problems here can cause erratic signals to be transmitted to the PCM, ultimately resulting in the DTC being triggered. Identifying and rectifying any irregularities at this stage can save time and prevent unnecessary component replacements. This troubleshooting step involves a thorough inspection of the CKP sensor circuit terminals, particularly focusing on the ground connections. Check the connectors to ensure secure connections at both the engine ground and the body ground. Poor grounding can significantly affect the functionality of electronic components by introducing noise into the system or creating unreliable connections. Similar to previous steps, inspect for any loose terminals that may lead to intermittent connections, which could be the underlying cause of the DTC P0339. As with other circuit inspections, confirming that connections are in normal condition is essential to maintain proper signal integrity for the CKP sensor. In this step, focus on the CKP pulse plate's condition. Before proceeding, ensure that the CKP sensor is removed from its housing location to allow for a clear inspection of the pulse plate. The CKP pulse plate generates the reference pulses that the CKP sensor detects, so any physical damage or looseness could result in an inaccurate signal being sent to the PCM. Carefully inspect the plate for signs of wear, cracks, or any looseness that would prevent it from functioning correctly. If the pulse plate appears to be compromised in any way, it could directly contribute to the DTC P0339, necessitating repair or replacement as part of the overall troubleshooting process. The final step in troubleshooting the DTC P0339 involves inspecting the CKP sensor itself. Following all previous inspections, if no other components show abnormalities, the remaining suspect is the CKP sensor. It is necessary to test its functionality to determine whether it is operating correctly. If the sensor fails to produce the correct output signals, it is indicative of a fault within the sensor itself. Replacing the CKP sensor may be required to resolve the issue, returning normal operational conditions to the vehicle. This step wraps up the thorough inspection and pinpoints the cause of the DTC if all other criteria have been checked and passed. Once all troubleshooting steps are complete, the final repair verification is crucial to ensure that the DTC P0339 has been adequately addressed. Begin by rechecking the HDS to confirm if the DTC is still present after any repairs or component replacements made. If the DTC is no longer displayed, it is essential to test the engine to confirm that it operates correctly and that the CKP sensor circuit now functions properly. This verification phase is critical for affirming that the repair efforts have resolved the underlying issue. Successful resolution not only improves engine performance, but also enhances overall vehicle reliability. To mitigate the reoccurrence of DTC P0339 in the future, implementing preventive maintenance is essential. Regularly check the connections at the CKP sensor and the PCM for security. Maintaining solid electrical connections can prevent erratic signals caused by vibrations or corrosion. Additionally, inspecting the ground connections for any signs of corrosion or looseness is vital, as these issues can directly impact the function of the sensor. Keeping the CKP pulse plate free from damage and avoiding exposure to harsh conditions can further prevent failures. By performing these regular inspections and routine maintenance, the longevity and reliability of the CKP sensor circuit can be ensured, reducing the risk of DTC codes resurfacing. In conclusion, effectively diagnosing and resolving DTC P0339 is essential for optimal engine performance in the Honda Accord 2023 Plus. Understanding the importance of the CKP sensor in the engine's operation and its role in sending essential signals to the PCM can lead to more focused troubleshooting. Following each outlined step meticulously can ensure a comprehensive approach to diagnosing the issue. Maintaining circuit integrity is pivotal, as every connection and component plays a part in overall functionality. Finally, engaging in regular inspections and preventive maintenance practices will provide long-term benefits, reducing the likelihood of future sensor-related issues. By being proactive, vehicle reliability can be significantly improved. Please like and subscribe to the channel. See you next time.